The discovery. Dr. Elena Santos stared at her computer screen in the dimly lit control room of the Arecibo Observatory, her coffee growing cold beside her keyboard. The signal pattern she'd been tracking for the past 3 weeks had appeared again, stronger than ever. This wasn't random space noise or a satellite echo. It was structured, repeating, and unlike anything she'd ever seen before. She reached for her phone, hesitated for a moment, then dialed. Dr. Chen, you need to see this. Within an hour, the observatory's main control room had transformed from its usual quiet state into a hub of intense activity. Dr. James Chen, the facilities director, leaned over Elena's shoulder, his eyes fixed on the scrolling data. It's not just a signal, Elena explained, pulling up multiple data windows. It's like they're talking about us. The pattern matches our global communication frequencies. Someone out there is discussing Earth's telecommunications. The signal originated from what they had previously thought was a dead zone, a region of space that showed no signs of astronomical activity. Now it was lighting up their instruments like a Christmas tree. Have you run the verification protocols? Dr. Chen asked, though he already knew Elena would have. 3 times. This is real, James. We're picking up conversations about Earth from something that's about 40 light-years away. And from what I can tell, she paused, double-checking her calculations. They're not very impressed with us. In the following days, as the world's major observatories turned their attention to the source of the signals, a clearer picture emerged. The transmissions weren't meant for human detection. They were administrative chatter, bureaucratic reports about a primitive developing world. Elena and her team worked around the clock, decoding more of the transmissions. The aliens who referred to themselves as the Concordiate had been observing Earth for centuries. Their reports were clinical, dismissive. Species shows standard development patterns, relies on inefficient chemical propulsion, primitive digital computing, recommend standard observation schedule. What frustrated Elena most wasn't the aliens' presence. It was their patronizing tone. Every transmission treated human achievements as quaint, predictable steps on a predetermined path. The discovery of nuclear fission, expected developmental milestone. The Internet, standard information sharing evolution. Even humanity's first steps into space were logged as typical early-stage exploration attempts. But as Elena dug deeper into the signals, she found something the Concordiate had missed. Hidden in their own transmissions was evidence that humanity's approach to physics and technology wasn't just different, it was unique. Where the Concordiate had followed a linear path of technological evolution, humans had explored countless alternative theories and methods. They're so advanced they've become inflexible, Elena explained to Dr. Chen one evening, spreading out pages of decoded transmissions. They've optimized their technology so much that they've lost the ability to think outside their established frameworks. And you think this matters? Dr. Chen asked, studying the data. I think it matters a lot, Elena replied, pulling up a comparison of human and Concordiate approaches to quantum mechanics. Look at this. We're solving the same problems they are, but from completely different angles. They've mastered one path so completely that they've forgotten other paths exist. As if to prove her point, a new signal came through that night. The Concordiate was puzzled by human experiments in quantum entanglement, not because they were primitive, but because humans were approaching it from a direction their civilization had never considered. Elena smiled as she logged the transmission. The Concordiate thought they were observing a predictable primitive species, but they were about to learn that humanity's greatest strength wasn't in following the expected path. It was in finding new ones that no one else had thought to explore. Little did the Concordiate know, their dismissive reports about Earth were about to become the prelude to one of the greatest surprises in their civilization's history. Humanity was about to prove that sometimes the most revolutionary discoveries come from those who don't know they're supposed to be limited by the right way of doing things. The underestimated. The Concordiate's first official contact with Earth came not with the dramatic flair of science fiction, but through a conference call. 6 months after Elena's discovery, Representatives from major world governments and scientific institutions gathered in a secure virtual meeting room to face a holographic projection of senior observer Kelrix, whose crystalline form seemed to shimmer with barely concealed condescension. "We have been monitoring your development for some time," Kelrix announced, their voice translated through an AI interface. "Your species has progressed adequately along the standard technological path. We are here to offer guidance toward your eventual integration into galactic society." Dr. Maya Patel, sitting in her lab at MIT, fought to keep her expression neutral as Kelrix displayed a timeline of human development with helpful arrows pointing to where the Concordiate could optimize human progress. Next to her, Dr. Thomas Rivera, a quantum physicist with a reputation for unconventional theories, was practically vibrating with contained energy. "Your current approach to quantum mechanics," Kelrix continued, displaying complex equations, "while admirable for your development stage, could be greatly improved by adopting our standardized methods." Maya watched Thomas's hand shoot up. She knew that look in his eyes. It was the same one he'd had when he proposed his controversial quantum friction theory that the scientific community had initially dismissed. "Actually," Thomas interjected, "we've been working on something that might interest you." He shared his screen, showing data from his latest experiments. "We found that quantum states can be manipulated through what we call resonance harvesting, using the natural frequency of particle vibrations to—" "Impossible," Kelrix interrupted, their crystalline form flickering with what might have been amusement. "Such methods were proven inefficient millennia ago. The standardized approach clearly demonstrates. But look at the results." Maya jumped in, supporting her colleague. She pulled up their latest test data. "We're achieving quantum coherence at room temperature using less energy than conventional methods." The holographic aliens seemed to freeze for a moment, their translation eye struggling to process this information. "Your measurements must be flawed. These results contradict established principles." "Or maybe," Thomas suggested, "there's more than one way to approach quantum mechanics." Over the next few hours, as the conference continued, a pattern emerged. Each time the Concordiate representatives presented their superior methods, human scientists would counter with approaches that, while seemingly less advanced, achieved similar or sometimes better results through unexpected means. Dr. Sarah Chen, a young researcher from Dr. Elena Santos' team, presented her analysis of the Concordiate's own transmissions. "Your civilization has optimized one path of technological development to an incredible degree," she explained. "But in doing so, you may have missed alternative possibilities." The meeting reached its climax when Maya revealed their latest breakthrough, a hybrid system that combined human primitive approaches with principles gleaned from studying Concordiate transmissions. It was crude by alien standards, held together with what amounted to the quantum equivalent of duct tape and paper clips. But it worked in ways the Concordiate's models said were impossible. "This is highly irregular," Kelrix announced, their crystalline form now pulsing with patterns that their AI couldn't quite translate. "We will need to consult with the Concordiate's Science Council. Such unorthodox methods require further study." After the aliens disconnected, the human scientists sat in silence for a moment before Thomas started laughing. "Did you see their reaction when we showed them the resonance harvester? I thought their hologram was going to crash." Maya smiled, but her mind was already racing ahead. "They're going to come back with more questions. We need to be ready." She pulled up the data from their hybrid system. "If they think this is irregular, wait until they see what we're working on next." In her office at Arecibo, Elena Santos received the meeting notes with a growing sense of satisfaction. The Concordiate had expected to find a primitive species eagerly awaiting guidance. Instead, they'd found humans doing what humans did best, finding new ways to solve old problems. As she reviewed the transcript, a new transmission from the Concordiate caught her attention. Their bureaucratic tone had changed. Words like anomalous and requires investigation had replaced primitive and standard development. Humanity had just moved from being a footnote in their observations to being a puzzle that needed solving. Little did they know, this was just the beginning. In labs around the world, human scientists were already taking apart the Concordiat's perfect theories and rebuilding them in ways their alien observers had never imagined possible. The age of standardized development was about to meet its match in human ingenuity. The breakthrough. Dr. Maya Patel's laboratory looked like what would happen if a scrapyard collided with a quantum physics lab. Salvaged computer parts sat next to state-of-the-art measurement devices, while a modified microwave oven hummed ominously in the corner. Thomas Rivera called it organized chaos. Maya called it innovation. It's not pretty, she told the gathered team of international scientists, but it works. On her workbench sat what looked like a mess of copper wiring, crystal matrices salvaged from studying Concordia transmissions, and what appeared to be parts from an old radio telescope. The device hummed with a sound that made the air feel thick. "We're calling it the resonance bridge," Thomas explained, pulling up diagnostic readings. "It combines our primitive radio wave technology with principles we've derived from Concordiate quantum mechanics. According to their models, it shouldn't work at all." Dr. Sarah Chen studied the readings with growing excitement. "You're using radio waves to manipulate quantum states. That's like using a hammer to perform surgery." "More like using a tuning fork," Maya corrected. "We found that certain frequencies of what the Concordiate considers crude electromagnetic radiation can influence quantum particles in ways their standardized methods never explored. They're so focused on pure quantum manipulation that they overlooked simpler solutions." The breakthrough had come 3 weeks after the first contact meeting. Maya had been studying Concordiate quantum theories when she noticed something they'd missed. Their perfect, standardized methods had a blind spot. They'd become so advanced that they'd forgotten the fundamental principles they'd built upon. "Look at this," she pointed to a holographic display showing wave patterns. "The Concordiate uses incredibly complex quantum fields to achieve particle entanglement. But we found that by using basic radio waves at exactly the right frequency, we can achieve similar results with a fraction of the energy." Elena Santos, joining virtually from Arecibo, spoke up. "The latest Concordiate transmissions show they're still trying to understand how we're achieving these results. Their models can't explain it because they literally wrote off these possibilities millennia ago." The team had dubbed it the primitive advantage. Human technology, being less advanced, was forced to work with fundamental principles that the Concordiate had long since abandoned for more efficient methods. Like a master chef discovering that sometimes a stone tool could work better than a laser cutter. "But here's the real breakthrough," Thomas said, activating the resonance bridge. The device pulsed, and suddenly the quantum readouts showed something unprecedented. They weren't just matching Concordiate capabilities, they were exceeding them in certain areas. "We're not just using their technology," Maya explained as the team stared at the results. "We're reinventing it." The Concordiate optimized their quantum manipulation to perfection, but they only explored one path. "We're finding dozens of alternatives they never considered." The implications were staggering. Humanity wasn't just catching up to Concordiate technology. They were developing entirely new branches of physics that the aliens had missed in their rush to standardization. News of the breakthrough spread quickly through the scientific community. Labs around the world began experimenting with hybrid technologies, combining primitive human methods with advanced alien principles in ways that defied conventional wisdom. In her office, Elena intercepted a new batch of Concordia transmissions. Their tone had changed dramatically. Words like anomalous and impossible appeared with increasing frequency. The aliens were struggling to understand how humans were achieving these results with technology they considered obsolete. "They're starting to realize their mistake," she told Maya over a video call. "They thought technological development was a straight line, with their methods at the peak. We're showing them it's more like a tree with countless branches they never explored." Maya nodded, looking at the resonance bridge. "The funny thing is, we're just getting started. Wait until they see what happens when we apply these principles to other fields." The device hummed quietly, its seemingly crude construction belying its revolutionary nature. In labs across Earth, similar devices were being built and improved upon, each one proving that humanity's primitive approach to science wasn't a weakness, it was their greatest strength. As Maya's team prepared to publish their findings, a priority transmission arrived from the Concordiat. The Science Council requested an immediate conference. They had questions, many questions, about how humans were achieving these impossible results. Maya smiled as she read the message. The Concordiat was about to learn that sometimes the most profound discoveries come not from perfecting the known path, but from having the courage to forge new ones. Humanity's era of being dismissed as primitive was over. The age of innovation had begun. The crisis. The alert came at 3:47 a.m. Earth time. Elena Santos was awakened by an urgent transmission from the Concordiat. Not their usual bureaucratic reports, but a priority distress signal. As she decoded the message, her blood ran cold. "They're calling it a cascade failure," she explained to the emergency conference 2 hours later. Scientists and government officials from around the world watched as she displayed the data. Something is causing quantum fields to destabilize across their networks. Their standardized systems are falling like dominoes. On screen, Kelrix's crystalline form flickered more than usual, their normally precise patterns showing signs of distress. "Our quantum network spans 17 star systems," they explained. "The disturbance began in the Proxima sector and is spreading. Our standardized safeguards are ineffective." Maya Patel and Thomas Rivera exchanged glances. "Your systems are too perfect," Maya said, studying the cascade patterns. "They're all based on the same quantum principles, optimized to the point where they can't adapt to unexpected variations." "Precisely why we need your assistance," Kelrix admitted, their translation eye struggling to convey their discomfort at asking primitives for help. "Your unorthodox methods may provide insights we cannot see." The situation was dire. The Concordiat's quantum network didn't just handle communications. It regulated everything from power distribution to artificial gravity in their habitats. As the cascade failure spread, entire star systems were going dark. "Look at this." Sarah Chen pointed to a particular data stream. "The failure pattern. It's like quantum resonance gone wrong. Similar to what we saw in our early bridge experiments." Maya's eyes widened. "When we were still using radio waves to influence quantum states, and getting interference patterns that the Concordiat said were impossible," Thomas finished. "What if that's our answer? Fight quantum with classical." The next 12 hours were a blur of activity. While the Concordiat's finest minds tried to combat the cascade failure with increasingly complex quantum solutions, the human team took a different approach. They'd modified their resonance bridge technology to work on a massive scale. "It's like using analog signals to stabilize digital networks," Maya explained to a skeptical Concordiat Science Council. "Your quantum systems are too entangled, too perfect. We can use crude electromagnetic waves to introduce controlled chaos into the system." Controlled chaos. A counselor's crystalline form pulsed with confusion. "That contradicts all established principles of quantum stability." "Exactly," Elena interjected. "Your principles are the problem. You've optimized your way into a corner. Sometimes you need inefficiency to create stability." The council debated for precious minutes while more systems went dark. Finally, Kelrix spoke. "Proceed with your primitive solution." The plan was beautifully simple in its inelegance. Using modified radio telescopes and hastily constructed resonance bridges, Earth began broadcasting specific frequencies into space. The crude radio waves interfered with the quantum cascade in ways the Concordiat's perfect systems couldn't predict or prevent. "It's working," Sarah announced, watching the data streams. "The cascade is slowing, stopping, reversing in some sectors." The Concordiat observers watched in stunned silence as humanity's supposedly primitive technology did what their advanced quantum systems couldn't, like using a garden hose to stop a quantum fire. Hours later, as the crisis subsided, Maya found herself explaining to the Concordiate Science Council exactly how they had saved a 17-star civilization using technology that predated spaceflight. "Your quantum network was too perfect," she said, showing them the principles behind their solution. "Every system identical, optimized, standardized. But nature isn't standardized. Sometimes you need imperfection to create resilience. This challenges everything we believed about technological progress." Kelricks admitted, their crystalline form showing patterns that their AI translated as a mix of humility and excitement. "That's because you stopped challenging yourselves," Elena responded. "You found one perfect way of doing things and stopped looking for alternatives. Humans never stop looking." As the emergency conference wound down, Thomas noticed something in the data streams. "The quantum interference patterns we created. They're showing properties we've never seen before. I think we just accidentally invented a new form of quantum manipulation." Maya laughed. "Leave it to humans to make a breakthrough while fixing something with the equivalent of space duct tape." The crisis had passed, but its implications would ripple through both human and Concordiate civilization. Earth's primitive technology hadn't just saved the day. It had opened up entirely new avenues of scientific exploration that the Concordiate's pursuit of perfection had overlooked. In her lab, Maya looked at their jury-rigged resonance bridge, now modified with new insights gained from the crisis. "You know what this means?" she asked Thomas. "We're not just catching up to them anymore. In some ways, we're surpassing them." "Because we never forgot how to think simple," Thomas replied, already sketching out new modifications. "Sometimes the best way forward is to remember where you came from." The Concordiate would never look at primitive technology the same way again. Sometimes, the path to the future requires a step back to move forward in a new direction entirely. The partnership. 1 year after the quantum cascade crisis, the Arecibo Observatory had changed beyond recognition. Crystalline Concordiate technology merged seamlessly with Earth's primitive equipment, creating a hybrid facility that embodied the new relationship between the two civilizations. Elena Santos stood with Kelricks, watching as human and Concordiate scientists worked side by side. The aliens' crystalline form had adopted new patterns that their translation AI now recognized as expressions of curiosity and enthusiasm, emotions that had been considered inefficient in their former rigid hierarchy. "Your latest prototype," Kelricks observed, gesturing to Maya's newest version of the resonance bridge. "It combines our quantum matrices with what you call rabbit ears antenna technology." Maya grinned. "Sometimes the old solutions are the best ones. The antenna gives us finer control over the quantum fields than your pure energy manipulators. Less efficient on paper, but more adaptable in practice." The breakthrough that had saved the Concordiate's network had sparked a revolution in both societies. The aliens had begun re-examining technologies they'd dismissed millennia ago, while humans were finding ways to combine their primitive approaches with advanced alien principles. "We were wrong," Kelricks admitted, their crystalline form shifting to patterns that indicated deep reflection. "We thought technological progress was about perfecting a single path. You showed us it's about exploring all possible paths." Thomas Rivera, who had been monitoring a new experiment, joined them. "That's humanity's greatest strength," he said. "We never stop asking, what if? Even when we're told something's impossible, we try it anyway. Sometimes we fail spectacularly, but sometimes you succeed in ways we never imagined possible." Kelricks finished. "Your species' stubborn refusal to accept limitations has taught us more in 1 year than we learned in the previous 1,000. The evidence of this new partnership was visible throughout the solar system. Earth's space program had leaped forward by incorporating Concordiate technology, while the aliens had begun modifying their ships with surprisingly effective primitive backup systems." Sarah Chen, now heading the Joint Human Concordiate Innovation Division, pulled up a holographic display of their latest project. "We're calling it the Genesis Initiative," she explained, "a complete rethinking of how technology can evolve." The display showed a new type of quantum computer that deliberately incorporated elements of chaos theory and analog processing. It wasn't as streamlined as traditional Concordiate systems, but it was more resilient, more creative, and capable of solving problems in ways pure quantum computers never could. "It's beautiful," Elena remarked, watching the hybrid system at work. "Not because it's perfect, but because it's adaptable. Like life itself." The Concordiate Council had undergone its own revolution. After millennia of rigid standardization, they had created a new division dedicated to exploring alternative development paths, essentially, learning to think more like humans. "Your civilization reminded us of something we have forgotten," Kelrick said, watching a group of young Concordiate scholars excitedly discussing ancient technologies with human scientists. "Progress isn't just about reaching the destination. It's about exploring every possible path along the way." Maya's team had just finished testing a new communication system that used modified radio waves to stabilize quantum entanglement. "It's less efficient than pure quantum transmission," she explained to a group of Concordiate engineers, "but it can adapt to interference patterns that would crash your standard systems." "Inefficient but adaptable," one of the alien engineers mused, their crystalline form showing patterns of appreciation. "Like your species." The partnership had transformed both civilizations. Humanity gained access to advanced technology while maintaining their innovative spirit, and the Concordiate rediscovered the value of exploration and unconventional thinking. In her private moments, Elena sometimes reread the first Concordiate reports about Earth, their dismissive tone, their certainty that humanity would follow the standard development path. She couldn't help but smile at how wrong they'd been. "We've got something new on the Genesis prototype," Thomas called out, drawing everyone's attention. "The hybrid system just solved a quantum paradox by using what appears to be a modified version of 21st century search algorithms." Maya laughed. "Of course it did. That's what happens when you combine primitive human ingenuity with advanced alien technology. You get something greater than the sum of its parts." As the team gathered to examine the results, Kelrick's form displayed patterns that the translation AI interpreted as profound satisfaction. "Perhaps," they suggested, "we should stop using terms like primitive and advanced. After all, true progress comes not from following a single path to perfection, but from having the courage to explore every possible path, even those that seem to lead backward at first." The future stretched out before them, full of possibilities that neither civilization could have imagined on their own. Together, they had learned that the greatest discoveries come not from perfecting what is known, but from having the courage to explore what might be possible. And somewhere in the vast network of hybrid technology that now connected Earth to the stars, a quantum computer using modified radio waves solved an impossible problem by trying something that everyone else had dismissed as too primitive to work, proving once again that sometimes the best way forward is to remember where you came from.